Ready to go? Morning. Hello, Rebecca.
Hello, Mr. Sharar.
What are you doing here?
Need my binder?
Okay. Hello, Jessica. Morning, Giovanni. Morning. Felix, good morning. Carlos, good to see you, sir. I didn't film you that time. I'm going to film you this time. This week. It's super cool. Hi, Lily. Good morning. You guys done? You need that. I'm going to explain it at the end of class. Hello, Zach.
Here.
Hello, Kenya. Good morning, Jefferson. Hi, Mari. Good morning, Mr. Monzo. Chelsea Ramos, good morning. Good morning, good to see you. Osvaldo, good to see you, sir. Hello, sir. Melda. I'm sorry. Good to see you, though. Thanks for being here. Hello, Julie. Good morning, Mike. And Noah, good morning. Jessica, good to see you. Hi, Noah. So all you need is to take out your handout from yesterday. I'm going to come around and check your homework later, but now just have it out because we're going to need to use it for today's materials. What are we missing? Nikki. Okay, as you're taking that out, just a few announcements. Last day for revisions is next Wednesday. The reason for that being your unit exam is on next Thursday, covering everything from this semester. So if you want to do any revisions for any learning targets, you need to do them by next Wednesday. The lab we did yesterday, pretty fun. We're going to analyze the data today. You'll start working on your lab report for it today. The final draft of your lab report will be due on Monday in your notebook that you turn in to me. Any logistical questions about that stuff? Okay. Quick photo of the day. There we go. So backstory to this. My sister's birthday is in about a week and a half, and she's like, I really want to do something. She just moved to the Bay Area. She lives down here now. She's like, I really want to do something fun. I'm like, cool, I like fun. Like, I'm down with that. What do you want to do? She's like, I want to go skydiving. And I'm like, okay, maybe. And so then I was just kind of looking on the internet for what are some like other cool adventurous activities, and I found this thing, which I don't know if anyone's seen before. Basically, there are these jet packs that you can ride around above bodies of water, and they work just by pumping water up through these tubes and then propelling it down with enough force to kind of keep you up in the air, and you can kind of fly around like on a jetpack, which is kind of cool. I have no idea how much this costs or if you can even do it in the Bay Area. This is a picture from somewhere in Miami, but it looks a little safer than skydiving. That doesn't mean I'm not going to do it, but there are other options out there. Other options. Okay. Today, we have two things that we're going to work on. First objective today, Gabe, is what?
Explain how changes in temperature and surface area affect solubility.
Excellent. So this is a new word, new vocab word we're going to learn today. So please repeat after me. Solubility.
Solubility.
One more time. Solubility. Excellent. So therefore, our second objective, Justel, is? Okay, we want to know what that means. It says solubility questions for homework. That's not your homework, so don't write that down. Sorry. Okay. Don't worry about it. Your homework will be something different that I'll explain at the end of class, so don't fret about it now. Okay? So, to get at this term solubility, let's launch right to it, because I want to give you a lot of time to work on your lab reports today. So, here's a sentence with the term solubility used in it, or the word soluble used in it twice. Nesquik chocolate powder is soluble in water. However, Nesquik is more soluble in milk than in water. So everyone, we're looking at this handout. I see us flipping through stuff. Make sure we're on the right page here. Okay. Based on that sentence, I want you to answer number one. What do you think the word soluble means? What do you think the word soluble means? Go ahead and take about a minute just to jot down, based on that context alone, what do you think the word soluble means? Just write it down. Just your thoughts. Just your thoughts. Handout from today. We'll talk about that later. About 10 more seconds. Go ahead and turn to your partner. Take a quick opportunity to share. What do you think the word soluble means? Go. So what'd you say, Aldo? Okay. Did you say anything different, Roberto?
It's like better combined, better broken down in that particle.
Okay, cool. Was there another word that we learned for broken down? Or what did you say, Jefferson?
Ability for a solid to dissolve.
Cool, so that works also. Exactly right. Beautiful. Bring it back together in 3. Mouths closed in 2. Eyes up front. In 1. I got half of us. I still got only half of us. Cool. So, one context here, the word soluble. Jorge, what did you say?
I said, I guess, more dissolving.
Okay, so how well it can dissolve, something like that? Guess what? That's exactly right. That's exactly what this term means, okay? You guys are using context clues. We've practiced with this in the lab. It's easy to put it together. If we were to formally define solubility, it's a measure of how well a solute dissolves. Okay? So as Jorge said, it's how well something dissolves, but we can actually measure that numerically. Okay? So I'm going to show you some data in a second that's sample data of what solubilities look like. Okay? So here are 3 compounds and their solubilities. These are typical of like what you would see in a data table, so we want to be familiar recognizing these. So 3 different compounds, they all have chlorine. So we have sodium chloride, potassium chloride, and calcium chloride. And here are their solubilities in water, in 1 liter of water. So if you took one beaker like this, you had it filled with water, this number means is if you had NaCl powder, salt, you could take 35 grams of it and it would all dissolve in the water. That'd be the maximum amount you could dissolve. Okay? If you had another beaker with a little water and you had to dissolve potassium chloride in it, KCl, you could only dissolve 32 grams in it. But CaCl2, you could dissolve up to 74 grams in the same volume, in the same 1 liter. So my question for you just to think about in your head is, out of these three compounds, which has the greatest solubility and why? So out of these three compounds, which has the greatest solubility and why? Michael. Why do you say that? Exactly. Okay. Bigger number, greater solubility. Lower number, lower solubility. So we want to be familiar with those numbers. All right. Yesterday we didn't collect solubility numbers. We collected times in the lab. The time it took for the lab to pop off. The lab to pop off. The lid to pop off in the lab. Okay. So what I did is I grabbed one group's data from yesterday because it was pretty representative of everyone's data as a class. So I'm just going to share that with us together, and then we're going to analyze it. So this group, they had 4 different temperatures. They had 12 degrees, so make a note of these, 25, 42, and then 70. Those were the 4 temperatures that they had. And the times that they measured in seconds for the lids to pop off were 18, 11, 7, and then 2. 18, 11, 7, and 2. So, based on that data alone, again, this is pretty typical of our class data, we want to think about the answer to number 1. What is the relationship between temperature and the amount of time it takes to pop the cap off the film canister? All right? So I gave you a sentence starter here, as the temperature. Okay. I want you to look at the data. Go ahead and take a minute right now. Complete that sentence. How is the temperature and the time related? So go ahead and take about 1 minute to complete that sentence by yourself. So how could you finish off this sentence? Giovanni, how'd you finish it off?
But as the temperature becomes hotter, the time for the lid to pop is reduced.
Excellent. Perfect. Okay. So I'm just going to rephrase that just using the words increase. As the temperature increases, the time seems to decrease. Okay. And I think almost all groups saw that yesterday. The hotter vinegar made the lid pop off a lot faster, even if you were one of the unlucky groups where the lid wasn't really popping off that well. I apologize. Okay? If you find more film canisters somewhere, you should bring them to me. Because I told you I've been to every Walgreens in this county. That's not true, but most of them. And they don't have them anymore. Or they won't let me dig through their trash at least. Okay. Another group had some surface area data that we should share and compile. So what they did is they did 4 different trials. They used the whole tablet, then they broke it up into 2 pieces, then they broke it up into 4 pieces, then they ground it up into a powder. And the times that they had were about 24, 18, 13, and 3 seconds. So same thing, you want to look for the trend. In number 2, what is the relationship between surface area and the amount of time it takes to pop the cap off the film canister? So go ahead, complete the second sentence, which should say, as the surface area dot, dot, dot. Go ahead and take a minute to finish off that sentence. Which one of these has more surface area? Do you remember what we talked about?
Yeah.
Which one?
Isn't it the one has the most surface area?
No, there's a trick that we used to remember. Remember, more pieces means more surface area. So which of the powder has the most surface area?
Yeah.
So what's happening as we increase the surface area? What's happening to the time?
This one goes faster.
Take about 10 more seconds. Yeah.
If it's going from a whole to 2 pieces, would that be considered decreasing or increasing?
More pieces means more surface area. So what about for the second relationship? What are we seeing in this case? Roberto.
As the surface area increases, the time it takes for the lid to pop out decreases.
Time. Excellent. Okay. Seeing the same trend. So just a quick refresher, if you guys were thinking about this. Powder, more pieces means more surface area. So we have these general trends. Great. We saw that from our data. Not good enough. We got to get more in depth. We got to understand why is that actually happening. What's happening with the atoms and with the molecules to actually cause the time that it takes to dissolve to go down, the lid to pop off be faster. So the way we're going to do that is you're going to be working with your partner. Okay. Flip to the next page. And there are 2 stations here. 2 stations. Arturo, you don't need your computer right now. Okay. 2 stations. If you are closest to me, if you look at the corner of your desk, you will have a piece of paper that says temperature on it. Okay? If you are further away from me, you will have a piece of paper at the corner of your desk that says surface area. Through these readings and these short questions that you're going to answer, you're going to be able to explain why changing temperature and surface area affects solubility. We'll do this in a way that we've done similarly before, a little peer teach method. So you'll read, you'll become a master of each section, then you'll be responsible for teaching your partner. Okay? Don't write on the handouts directly. Okay? As you read and think about the answers to the questions, put that information into your box for your section. Okay? Again, you're responsible for mastering one of them, your partner will get the other, and then we'll have time to peer teach each other afterwards. We've done this a few times before. You'll have 5 minutes just independently right now to become a master of your section. Again, closer to me temperature, further away from me surface area. Are there any questions? I'll put 5 minutes on the clock. Go ahead and get started. No, boy, take notes on here. Oh, yeah. So you need to get it and then bring it back to me as soon as you can. Yeah, so you're reading this section, right? Taking notes over here. Alright, so. Where's your section?
What?
Where's your section?
Right here?
Yeah, because you're going to use that information to do the explanation. So you want to answer me. That's the idea, but in your box. Bless you.
said add up the around the mint, just these two?
Yeah, so around mint A, what's the total surface area?
2, 4, 6, 8.
Exactly, okay. And then what about for mint B when it's the same mint but broken up into 4 pieces?
16.
Exactly. So now my question would be, which one has more surface area?
B.
Okay. And so then the question is, after you read this, you would want to think about why would this dissolve faster?
Okay.
Okay. And the thing to think about would be space and collisions. Those are some words to look for.
Okay.
Okay. Yeah, we're reading these. We're getting our notes here. What do you think? Yeah. Cool. So if you were to explain to me why does having more surface area increase solubility, how would you explain that to me in a sentence or two? What you kind of just started to do.
I guess that solvent molecules will help solid molecules dissolve faster.
Cool. And so why that? What's different about these two that would allow them to dissolve differently?
I guess it allows them to have more collisions to occur.
Perfect. And there's more collisions because?
Because I guess with more little pieces, I guess it allows for more molecules to attract.
Exactly. Yeah. And you kind of said it earlier. I'd say there's like more space here between the pieces, so there can be more collisions. So what you just said is a super thorough explanation. If you can put that into a sentence or two to teach Imelda, then you're perfectly good to go. So since you were at the temperature section, when they should teach their partners, you can just chime in to VNA if there's anything that they missed that you thought you should add. Otherwise, when she's teaching about surface area, I just want to listen to her to get the notes for surface area. Okay. Okay, so wrap up the notes that you're taking in the next 30 seconds or so. And I just want to have your eyes up here just so I can make sure our purpose of what you're trying to explain now is really clear. So if you just put your pencil down, eyes up front. So, it's very easy for you as you've read through this just to kind of now answer the questions and just share those answers to your partner. That's not what you want to do. What you want to be able to do here is essentially answer this kind of essential question. So if you were reading about temperature, why does temperature affect solubility? Why does making a solvent hotter make a solute dissolve faster? That's what you want to be able to explain using what you read as your explanation. Same thing for your surface area person. Don't just answer the questions on the handout. Use them as information to answer this overall essential question. Why does surface area affect solubility? So, let's see. Who's going to go first today? Temperature. You're closer to me. So, you got 2 minutes on the clock. You're answering that essential question. Surface area partner, you are taking notes based on what your partner says. Ready. 2 minutes. Go.
I read that as the temperature increases, the number of collisions between a solute and a solvent increases.
And I would add why. Why does that increase the number of collisions? There's a little piece of logic there.
This is because this causes the molecules to move faster.
Good.
And a solvent move around randomly faster. There's more
more collision between the solvent and the solute. So if there's more collisions between them, that means it's more likely to break apart and more faster.
Excellent. So think about what we did. Remember we acted it out outside? How would, if we had like heated ourselves up, how would that have looked differently in the way we were moving?
If we were to like heat ourselves up, I guess, so we'd be running. So that means we'd like hit more stuff like faster.
Right.
So it'd be like, so some guy would get hit 3 times faster than that.
And so the speed, the solubility would therefore increase. Exactly. Perfect. So that's the connection. Okay. Not yet. Temperature, folks, it sounds like we're about wrapped up. So I'm going to give you the freedom now. 2 minutes back on the clock. Surface area, it's your turn. 2 minutes, teach about surface area. It's a little more tricky to explain. Go. After you get these notes.
Where if you have a smaller surface area, it's like the saliva has less space to actually go through. And like in this example, the saliva was the solvent. So the solute, in this case, was the ment. It had to be broken down into many little pieces so the saliva could like go through all the pieces and dissolve it a lot faster.
Space for the solvent, which is saliva molecules, collide with solute molecules, and that's the mint. And they do this for more opportunities for collision to occur.
Cool. So maybe use the picture as an example, because you probably didn't see the picture yet, right, Lily? So maybe show what you mean by that. So show what you mean by that. Use that as an explanation.
It gets smaller and then it basically dissolves.
Yeah, but it wouldn't be as fast if you broke into pieces. So if you break into pieces, see there's like empty space over here? Your saliva can go through that, meaning it would have more room than if it was just going around it.
So do you see how there's more spaces for collisions to happen here than in here? And usually it might be kind of tricky because you think, oh wait, this is bigger, so there's more places to actually collide. But if you think about it, saliva can't get into the middle of that mint right now, right? Here, when it's broken up, it can get in. So there's way more opportunities for that solvent to collide with the solute, which is going to make it dissolve a lot faster. How do you feel about that?
Now,
How could explain it to me then? Why does having more surface area affect the solubility?
wait, I prefer this one because the saliva can get inside because, you know, even though like it has more room, for some they still can't get inside. But if you break it down, it has like the saliva can go. And then, you know.
Cool. So in this case, it's saliva, but in general, the term we would use would be the solvent. Good. All right, regroup back in 3, 2, 1, and 0. Things are sounding pretty good as I'm walking around checking in, but let's just summarize one key sentence or so for each one of these. And I'm going to do that with some symbols, a little symbolism here, instead of sentences, because this is the type of notation we'll start getting really familiar with as we go through this semester. So first, temperature and solubility. Why does temperature affect solubility? Osvaldo.
Well, the temperature affects solubility because with the temperature increasing, that means that the speed at which the atoms or the molecules in gas and liquid are speeding up as well. That means there's more chances for collisions between the solvent and the solute. And if there's more collisions, then that means the solute will break apart faster.
Are you guys aware of what just happened? Osvaldo just like dropped some knowledge on everyone. That was awesome. That was an incredibly thorough explanation. All right? Yeah, seriously. That's the type of detail we need to get to on any quiz or test or project or lab that we do. Okay? What I did is I took exactly what Osvaldo said, which was very eloquent, and I just put it into some symbols. As we increase the temperature, that increases the speed of the solvent, which causes more collisions, which increases the solubility of that particular solute. Okay? So this is just kind of a good way to summarize what was said there, to kind of remember it visually. But of course, any type of written assessment, a quiz or a test, you can't just put this. You got to use sentences and words. All right? Let's connect it to what we did last Friday. Remember we went outside on the basketball court and we acted out the dissolving process? Okay? Let's make that connection now. If we had heated ourselves up somehow, okay, what would have been different about how we moved around? What would have looked different? Yeah, Aldo. Who would have moved faster? The solvent, the water, right? So I could have said, everyone, if you're water, sprint. Okay? And then you've just been bouncing off each other everywhere. And we probably would have dissolved a lot quicker. So make that connection. That's a good visual to hold on to mentally. Excellent. Surface area. What's going on with surface area? Mr. Salinas.
The more surface area there is, the more room for solid molecules to comply with solid molecules.
Cool. So if we increase the surface area, there's more. Say that one more time.
There's more room.
So more, I'm going to say space for collisions. And there's more space for collisions. That's going to increase the collisions. And increasing the collisions increases the solubility. So again, same thing. I took Jose's excellent explanation, just kind of put it into some symbols that are a little bit clearer to manage and bite off. Any themes here? Do you see a word that's kind of popping up in both explanations? I heard solubility and what else? Collisions. This is the big idea. And especially as we move forward in talking about reaction rates and we talk about gases, it's all going to come back to this idea of collisions. So keep that kind of in your mind. That's the level of detail you need to get to in your explanations. So as you look at number 1 and 2, let's try to apply that detail now. Number 1 asks, Nesquik. When you go to buy Nesquik at the store, you buy chocolate powder. You don't buy chocolate cubes. Okay? There's a reason for that, based on what we know about chemistry. So, explain using the concept of surface area and solubility. So just go ahead and think about it for yourself. Why would they be using powder instead of chocolate cubes? And talk about it with your neighbor for a minute. What's the difference? Why would they be doing that? Go.
Chocolate syrup.
Ooh, so now we have a liquid-liquid interaction instead of a solid-liquid, so it's not necessarily a dissolving process that's occurring. Dissolving is between, usually when we talk about dissolving is a solute with a solvent. So if you think about it, a liquid, by definition, has much more surface area available to it than a solid, because it's miscible, it can just affect the shape of its container. So in that case, are you asking kind of does it have more?
Well, I mean, wouldn't it be a bit slower?
A bit what?
Slower in dissolving? Well, it doesn't dissolve though.
It does get dissolved.
Like,
The syrup?
I feel like it's harder to stir syrup than chocolate powder.
Yeah, I'd have to look into that. I'm not exactly sure of a thorough explanation. Yeah. So, difference here. What's going on? Why is Nesquik doing this, or are they just messing with us? Jose Torres, what did you guys talk about? Yeah, you're Jose Torres, right? Cool, just making sure. It is 7 months into the year. If I got that wrong, that'd be embarrassing. Okay. Beautiful. Excellent. Okay. Less surface area causes less collisions, a lower solubility, if it's a cube. Okay. Put that into words. Go ahead and answer number 2 afterwards. This connects to Coca-Cola. Why do soda companies heat up water before they add sugar to make the soda? Do the same level of explanation. Once you finish those explanations, log into your Chromebook, open up Google Classroom, and you can start working on your lab report for the lab we did yesterday. Okay? If you got any questions about these two, just raise your hand. I'll come around and check in with you. Otherwise, you got the rest of class to work on your lab.